We are talking about implicit differentiation today. Implicit differentiation, the functions in implicit differentiation, the functions that we have so far can be described by expressing one variable in terms of another variable. For example, y is equal to the square root of x squared plus 1, or y is equal to x sine x. Y is equal to x sine x. Or in general, y is equal to f of x. Since function, however, had defined implicitly by a relation between x and y, such as x squared plus y squared is equal to 25, x raised to power 3 plus y raised to power 3 is equal to 6xy. This consists of differentiating both sides of the equation with respect to x and then solving the resulting equation for the y, the x. So before we now go to the example 1, let me give the uh, the literary meaning of what I've able to have explained from the implicit differentiation. So what they just try to explain in implicit differentiation is that we have met so far can be described as expressing variable. What are just trying to say that there's some functions you see that y is a function of x. That is why we said y is equal to s sine x. Or we say y is a function of x. But sometimes we want to differentiate. We have x to be a function of x, x will also be a function of y, and we must differentiate the both sides with respect to x. So therefore, you will now differentiate the both sides of the equation. That is what we call implicit, and it involves a little bit explanation and a patience to understand these implicit differentiation. So once again, I will want everybody watching this video, if what you are doing is meaningful and interesting, we would like you to follow us, follow this page, and in the YouTube sections, you help us to subscribe to it so you can be able to see when we are releasing more video. So now we are starting the first example, so which is example 1. So we are now solving the example 1. If you're able to say from the example 1, he said if x squared plus y squared is equal to 25, find the y dx. Then find an equation of the tangent of the circle x squared plus y squared is equal to 25 at the point 3, 4. As I've said earlier, we are going to apply two formulas to solve this. The first formula to use in solving this is you firstly apply the way of, let's have a solution. Now let's apply the first formula to this. We said method 1. method 1. So in the process of this, let me have a longer line to divide the page into two. Let me give it a color to be in white form, or let's say in red form. We're going to give a meaningful. Okay, okay, okay. Don't let me give you white. Let me give you gray. So to have a meaning. So now let me pick it to. So it depends on where I need it. Oh, sorry. Yes, pick the 5 with it. So now, okay, good. So now in method 1, in solving these questions, so which we now want to explain. In the method 1, there's something which common here. He said x squared plus y squared is equal to 25. When you want to solve this, you said the derivatives of x squared plus y squared with respect to the x. You also do the same thing to this with respect to the x. So now, in differentiating this, in differentiating y, there's something I would like to want you to know. I want to differentiate this y with respect to x. It means that we are going to apply what you call a composite rule, the last one that we did, that is the chain rule, because it will give you this x square will give you 2x plus. Now y on its own, y is being function in y is function inside x. So the first thing you do, you differentiate y dot, because you have to apply chain rule to it. Why? You said y is function in x, so therefore you now differentiate the real y, which is the y dx. That is just the way it is, which is equal to 0. So therefore, if this is equal to 0, you now say the y 2y dy dx is equal to minus 2x. So let me pick this. So now you now have the y dx is equal to minus 2x over 2y, which is equal to minus x over y. So our formula here is that the y dx give us minus x over y. So now this is the formula for minus x over y, but the question continues to say that we are able to have gotten the value of the first derivative, which is the y dx. It now said that find the equations of the tangent. Remember, the equation of the tangent, equations of tangent also refers to when two lines are parallel. You now have m1 is equal to m2. So let me pick this as I want to copy it. Let me duplicate. Let me see to the next page again. Let me also duplicate. So now therefore, in a normal sense, you now said you have been given the value of x and y. Our s is equal to 3 and y is equal to 4. So if s is equal to 3 and y is equal to 4, therefore dy dx is now minus. So minus x will be minus 3 over y, that is 4. So making that the y, the x, is equal to minus 3 over 4. So meaning that our m1 is equal to minus 3 over 4, which is equal to m2 because the lines are parallel. We call it a tangent. So that is how. Now to now find the equations of the tangent, let's go to the next page. Recall that equation of tangent is y minus y1 over x minus x1 is equal to n. Now y minus our y1 is, from you able to see, our y1 we only give 1 point is 4 and our x1 is 3. Y1 is 4 and x minus 3 is equal to, so what is the gradient? The gradient is, which is the y, the x. So the gradient now is minus 3 over 4. So we have minus 3 over 4. So what you do, you cross multiply to have 4y, sorry, so I have y minus 4 is equal to minus 3 onto x minus 3. So we have 4y minus 16 is equal to minus 3x plus 9. So making 4y plus 3x is equal to 9 plus 16. Making 4y plus 3x is equal to 25. So that is the equations of the circle for the method 1. You know, as I've said earlier, I'm able to differentiate. What makes it unique here is that when you differentiate in implicit differentiation, after you differentiate y, I will just say like this. You apply chain rule, but the easiest method is after you differentiate that y with respect to another variable, which is x. You now differentiate the y again to give you the y, the x. That's just the logic to do that. So now, let's now go to the method 2. How does method 2 looks like? Now, let me explain the method 2. You know, the equation is this. He said x squared plus y squared is equal to 25. This is what the equation gives us, and this is what we want to differentiate now. So the one we know before is that we make y to be the functions of x. So to have that, we have y squared is equal to 25 minus x squared. So you find the square root, you have y is equal to the square root of 25 minus x squared. If you're able to see this, he said the functions of, we have our functions of s, f of s is now the square root of 25 minus x squared. So now, how do we now need the f of 1 of x, that is derivative. And recall, this can also be written as 25 minus s raised to s squared raised to power half. So in finding this with the chain rule, we have half onto 25 minus s squared. You subtract 1 from this, you have minus dots. So by the time you differentiate the inner one, that is the logic for the chain rule, we have minus 2x. So therefore, the functions of x will now give us. So this will cancel this. So we have minus x over 25 minus x squared all raised to power half. Recall is minus half, so by the time it become plus half, it will come down. So therefore, how do we now continue to have, let me pick the next table. So now you now have, this is your final answer. Now how do we now, let's now put the values of s and to compare the values of the gradient. So recall that our x is 3 from the point given, our x is 3 and our y is 4. So at these junctions, you're able to see that your x is 3 and y is equal to 4. So let's put it and see what the value will give us. We have something like minus 3 over 25 minus 3 square raised to power half will give us minus 3 over 25 minus 9 raised to power half is minus 3 over 16 raised to power half, which is square root of 16, which you can write to have root 16. So the derivative, the slope will now be minus 3 over 4. This now shows to us that you can rewrite this like this: minus x over 25 minus s squared, that is square root. Now this analysis lets us to know that all what I'm writing here is the derivative is now. I want to show you something. Now, showing to us here that our dy dx is equal to minus x over y, also minus x over square root of 25 minus s square. You see the meaning. You know, if you apply the y again from that question, you see, so it means all these are the same, just because, but they have different results in the they have different results in variable, but in slope the both value give us minus 3 over 4. So meaning that they were the same, minus 3 over 4. So that is just how it looks like, even from the first method and the second method. So I will want you to see that this is simple. That's why I solve it step by step. So this is example 2. In this example 2, we said A, find derivative of y if s cube plus y cube is equal to 6xy. That is the first question so far. And the B part, he said, find the tangent of the folio of the Descartes 6 s cube plus y cube equals to 6xy at the point of the same point. That is at the point when it is 3, 3. See at what point is a quadrant is a tangent line. At what point in the quadrant is the tangent line horizontal? So that is when at 0. So let's start firstly solve the derivative. So if we have, that is a, let's solve the a. You have s cube plus y cube is equal to 6xy. So let's differentiate this to give you 3s squared, as you know. Recall, this one will also give you 3y squared. But it's because it's y and we are differentiating with x. So that is why you must obey the chain rule. Dots y1. Can you just see? Y1 means dy dx. In differentiating this, what do you observe? You observe a product rule. A product rule. Now, the product rule here is, you know, u dv that is v du dx minus u dv dx. So let's firstly take 6. Let's differentiate x. Let's leave x. That is x dy dx. That is plus, because we are applying the product rule. That is u dv dx. So we will leave one to differentiate the other. So we are able to differentiate y. So here it will be 6y. Why? Because we have differentiated x. We have applied the product rule, because we firstly leave x, we differentiate y, plus 6, we differentiate x to give us 1. So it eliminates, now remain y. So that is the product rule issue. So we now continue to collect the like terms to have 3x squared. Let me make so we have 3y squared y1 minus 6x y1 is equal to 6y minus 3x squared. So in continue with this, y1 is common. We have 3y squared minus 6x is equal to 6y minus 3x squared. So let divide both sides by the coefficients of y1. So which we have 6y minus 3x squared over 3y squared minus 6x. So let's find something that common in both numerator and denominator. 3 is common here. You discover that we have 3 onto 2y minus x squared. If we're able to see here, 3 also common, we have y squared minus 2x. So 3 will cancel 3. There are y prime will now be 2y minus x squared over y squared minus 2x. So this is the value of our y1. So if this be the value of our y1, let's go to the b part. This is your differentiation. You just apply, you do it. Where the only way it is a little bit complex, it is when we apply the product rule here. So which is I'm able to have explained. So now let me go to the next page. Let's go to the next. So our y1 is 2. Let's say we have our y1. So let me write is 2y minus x squared. We have 2y minus x squared over y squared minus 2x. This is y squared minus 2x. So now the b part now say that when s is equal to y and is equal to 3. So let's find the slope. So y1 will now give you 2 onto 3 minus 3 squared over 3 squared minus 2 onto 3. So let's see what will give us. You have 6 minus 9 over 9 minus 6. Our y1 will now be minus 3 over 3, which is equal to minus 1. So that's all. The value is just like that. So, but this is the slope. This is just the slope. Let me double. So now this is just the slope. Now, we now want to find equation. Recall, I've said earlier the equation of the tangent from the question so far. He said, find the tangent, find the tangent, that is the equation of the tangent. Recall that the equation of the tangent is one that will be the roots of the parallel, which says that our m1 is equal to m2, which is equal to minus 1. So we call it a parallel lines. So therefore, we have something like, so y minus y1 over x minus x1 is equal to the gradient. So our y1, which is 3, x1 is also minus 3 is equal to minus 1. So what needs to do here is to cross multiply, so we can be able to get exact value. We have y minus 3 is equal to minus 1 onto x minus 3. So y minus 3 is equal to minus x plus 3. So we have y plus x is equal to plus 3 plus 3. So making y plus x is equal to 6. So that is just the equations of the equations of the tangent. So if that one should be the equation of the tangent, so let's now find the c part. So let's find the c part. So now how do we find the c part? He said find the tangent if it's horizontal. So there's some terminology needs in that area to explain horizontal pattern. So we are solving the C part now. So he said, let's see the C part. He said, at what point is the quadrant is the tangent line horizontal? So there's some terms in differentiations. We call it at horizontal level when there's a curve like this. So at a turning point, the y, the s is equal to 0. So that is means that our y1 must be equal to 0. So if our y1 is 0, meaning that 2y minus s squared over y squared minus 2s is equal to 0. So by the time they cross multiply, we have 2y minus s squared is equal to 0. 2y is equal to s squared. So that's, so now you now make your y to be the subject of the formula. So our y now is equal to the half of s squared. So if our y is half of s squared, but let's remember the equation. The equation is this: s cubed plus y cubed is equal to 6xy, and we have been able to know the value of y to be half onto s squared all raised to power 3 is equal to 6x onto half onto s squared. So let's continue manipulating this. We have s cubed plus s raised to power, because you apply this is from power 6 over, so apply this, that is 2 raised to power 3 is equal to 6 s cubed. This is 1 plus 2 all over 2. So we have s to power 3 on plus s raised to power 6 over 8 is equal to 3s cubed. Now, if it's not 3s cubed, let's try to do something. We have raised to power 6 over 8 is equal to 3s cubed minus s cubed. So we have s raised to power 6 over 8 is equal to 2s cubed. Now, in continuation to this, you now discover that s raised to power 6 is the same thing as 16 s raised to power 3. So is equal to 16 s raised to power 3. That is, so now let's now try to do something that to find the value of x. So let divide both sides by s raised to power 3, s raised to power 3 is equal to 16 s raised to power 3. So this becomes this. So s raised to power 6 minus 3 will now give you 16. S to the power 3 is equal to 16. So now we can now say that s to the power 3 is equal to 2 raised to the power 4. So therefore our s will now be 2 raised to the power 4 or raised to the power 1 over 3. So we have our s to be 2 raised to the power 4 over 3. So let's do something now. So now, if our x is now 2 raised to the power 4 over 3, that is the value of x. But from the analogy from the beginning, it let us know that our y is equal to 1 over 2x s raised to the power squared. So therefore, our y will now be 1 over 2 on 2. So which is the value of s is 2 raised to the power 4 over 3 all squared. So therefore, now since it is now squared, we now have y is equal to half dot 2 onto it will multiply 8 over 3. But recall, this is y can also be 2 raised to the power minus 1 dot 2 raised to the power 8 over 3. So from the law of indices, our y will now be 2 raised to the power minus 1 plus 8 over 3. So by the time we find the LCM, it will be 2 raised to the power. LCM is 3. It will be minus 3 plus 8. So our final value of y will now give us 2 raised to the power 5 over 3. So now, we now said from the analogy, of this, so the final answer here will now give us that the tangent is horizontal. At this point. The first point is 2 raised to power 4 over 3, and the second point is 2 raised to power 5 over 3. This is exactly where is at the point. So this is exactly, if you're able to see these explanation, I try to explain it in a way that you get it clean and clear. You just apply, but if you study, mathematics is one, because we have been using the indices, the numerator, the fractions, and all that. So you must be able to understand the basic principles of indices. So we also will soon go to another example, which will also explain another pattern. But you also study this explanation that it deals about the equation of a tangent. You see, you have another one that has the equation of a normal. A tangent is a parallel line, but a normal is a perpendicular line. So we go further now to the next example. So to explain this, so go to the next example. We are now in example 3. In this example 3, you have to study some things there. He said find derivative of y if sine bracket open x plus y is equal to y squared cos x. In the left side of this equation, or maybe the way you view maybe the right side, where we have sine onto x plus y. If you're able to see how to differentiate in that area, we are going to apply chain rule. But the second part, where we have y squared cos s, we are going to apply product rule. So that is the reason why all these rules is very important to know. That is the embryonic stage of differentiation. So let's start solving this. So let's have a solution. So if we are to solve this, our y1 now, to get it, we have sine x plus y is equal to y squared cos x. So now, in solving this, by applying chain rule, you will not differentiate sy. You will differentiate sine theta. Let's just say sine theta to give you cos x plus y. That's just the logic. You will not differentiate the inner one. So when you differentiate x, you give you 1 plus when you differentiate y, you give you y prime. That is the y dx. Now, this is a product rule. uv, v du ds and u dv dx. So now, uv, so v uv, so let's differentiate one and leave other. So now, for example, we differentiate cos x. You now have y squared to derivative of minus sine x. With the meaning of product rule is you differentiate one, you leave other. The one you leave, you differentiate, you add them together. That's just the meaning of product rule. We are able to leave y squared, we have differentiate cos x. So therefore, if we now want to do this, so what we are going to do now is, so as I'm just explaining, so now we now say plus we are able to leave y. You will now differentiate y to have 2y y prime cos x. That is just the logic. Cos x. So therefore, let's expand this. We have cos x plus y. This is the meaning when you multiply by 1 plus when we multiply by y prime Now multiply cos x plus y. You able to see? Now the same applicable, we have minus y squared sine x plus 2y y prime cos x. So at this junction, what you now need is to combine the like terms. So you have y prime cos x plus y. From this, you said you take that one to the left side. By taking it to the left side, we have minus 2y. We have 2y y1 cos x, which is equal to, so this one is minus already, so we now have minus y squared sine x minus cos x plus y. You can collect the like terms in this form. Let me give another way to also collect the like terms. Let's leave cos x onto x plus y. Now let's bring this one plus, to have a positive side, plus y squared sine x is equal to, so this one is here already, 2y y1 cos x minus y prime cos x plus y. If you're able to see, you discover that they were the same. So therefore, you know that y prime here is common. You now rewrite to have cos x plus y plus y squared sine x is equal to y prime onto 2y cos x minus cos x plus y. So we now divide both sides by the coefficients of y prime. So let's write it out again. You can now say that, let me see the way it is, cos x plus y, cos x plus y plus y squared sine x is equal to y prime is common, here. So you have 2y cos x, 2y cos x minus cos x plus y, minus cos x plus y. So let's now divide by the coefficient of cos x of y prime plus y squared sine x over 2y cos minus cos x plus y. So this is just the answer, the derivative of y prime. So this is just it is. So if you're able to see from the explanation, we expand, we differentiate step by step. We have where we're supposed to apply the chain rule, we apply it. When we're supposed to apply the product rule, we also apply it. That is how you collect the like terms. So after collecting like terms, you now divide by the coefficients of the y prime. And we're able to get the exact values of the answer, which is has nothing to, that is a confirmed answer. That is how we used to be. So I also want you, so we are now solving the last example now, which is example 4, which if I were able to give you the class works to do. So we are explaining example 4. If you're able to see this example 4, it is want to differentiate in second derivative. This, in an implicit differentiations, we also have the first derivative, the second derivative, the third derivatives to any numbers that you want to differentiate. Now this example is explaining you want us to explain how we can differentiate in second derivative. So now, how does the example looks like now? He said y raised to power s raised to power 4 plus y raised to power 4 is equal to 16. So we also apply the same method to solve it. So before this, try to watch this video to the end so you can be able to gain some certain things that come up. So let's now go to the board and explain how it looks like. So now he said, if you now have s raised to power 4 plus y raised to power 4 is equal to 16. By implicit differentiations, we have 4s raised to power 3 plus 4y raised to power 3 y1. Because I've said earlier that we use chain rule in that, which is equal to derivative of 0. So we have, in a normal analogy, we have y1 give us minus 4s cubed. So therefore y prime will now give us minus 4s cubed over 4y cubed. So this we cancel this. So y prime now give us minus s cubed over y cubed. So this is just how it looks like. Now, the question has let us to know that we want to differentiate again. How do you differentiate this? The first thing you must know that you discover that if you are to find the second derivative of this, this is uv. So meaning that you must apply the quotient rule. And let's remind ourselves about the laws of the quotient rule. Said v du dx minus u dv dx over v squared. That is the formula for the quotient rule. So we now want to apply this quotient rule. So now, let's start differentiating. So our y second derivative, our v, you apply to be y cubed dot du dx, which is u, which is minus, you put a bracket, 3s squared, minus, what is your u? Minus s cubed dot, that's it, dv, our v is y3. So to give you 3y squared y1. Can you able to see? Over the v squared, that is y to the power 3 all squared. I'm just trying to apply the formula. Let me just put it outside. You now have minus 3 s squared y cubed. The minus will multiply minus, we have plus. You're able to see 3y squared s cubed y1 over y raised to power 6. Before I proceed here, most important thing so far is that the quotient rule method that we use, and I apply the formula directly. I put v where it's supposed to be and I differentiate you, but the only implicit around the x that matter. But recall, we want to try to do some analysis. Recall something that in this analysis, that our y1 is a terms already. Our y1, we have been given our y1 to be minus s cubed over y cubed. And recall that our x1 appear in the y2. So let's try to do something here. Therefore, our y2 will now be minus 3s squared y cubed minus 3s squared y cubed plus now 3y squared plus 3y squared s cubed dot the value of y1, which is minus s cubed y cubed. Let's put it in a bracket so to have a meaningful things. This is also over 1 divided by y raised to power 6. Y raised to power 6. But if you're able to study very well, you discover that in view of this, you say your y2 will now be minus 3s squared y3 plus 3. These two and this, it will be, so it will turn to minus again. So it will not be plus again because minus times plus turn to minus. So it will now be x onto 3 plus 3 here dot y onto 2 minus 3 over y raised to power 6. So therefore, y prime 2 is minus 3s squared y cubed minus 3s squared raised to power 6 dot y minus 1 over y raised to power 6. So therefore, okay, good. So therefore, we now have y second prime minus 3s squared y3 minus 3s raised to power 6 over y all over y6. So you now have some logic way. This is 1 xn. It will be minus 3s squared y cubed dot y minus 3s raised to power 6 all over y dot 1 over y raised to power 6. Because this is xn, but it's still dividing. So you now have y second prime will now give us, this is 1 already. It will be minus 3s squared y raised to power 4 minus 3s raised to power 6. If you're able to see, this is 1. So 1 plus 6 because of the law to give you y raised to power 7. Y raised to power 7. But let's try to do something. You discover that 3s squared is common. Let's put it minus 3s squared is common. E now remain one fact that when we remove 3s squared, here will be y4 plus s raised to power 4 over y raised to power 7. By the time you multiply again, you get the same value. But recall that our question from the beginning, that our question is s raised to power 4 plus y raised to power 4 is equal to 16. And can be written as y raised to power 4 plus s raised to power 4 is equal to also 16. Therefore, since our y second prime is equal to minus 3s squared on 2, you can rewrite this to be s raised to power 4 plus y raised to power 4 over y raised to power 7. As we all know that s raised to power 4 plus y raised to power 4 is equal to 16. So therefore, y raised to power second power will now be minus 3s squared times 16 all over y raised to power 7. So y second prime will now be, from the analogy, now be minus 48s squared over y raised to power 7. So this is the answer. So that is the final answer so far. I would like to appreciate those who watch this video to the end. Also, to the end of this video, you also stay tuned in the YouTube channel to subscribe to the channel in case of the next video releasing. So we appreciate all for this watching, and also for you having any questions, don't hesitate to drop your question in the comment sections so I can be able to answer all questions. In your Facebook comment section too, write your question there and put everything. I will be able to give the proper and final answer. So you're welcome again to this Olusegun Maths Clinic, where we're able to see a videos. So thanks for watching this video.